In this video, I will be going through a previous year's math investigation for grade 12 based on inverse functions. Now, I do understand that at the moment there are some schools in the country that are covering their math investigation based on trigonometry. So if you're doing trigonometry, it's going to be based on double angles, compound angles. I have already made a video based on that, so if that is a section that you're going to be tested on, please check out that video instead. If you are writing on inverse functions, then this is the video for you. So I've managed to find this previous year's math investigation. It's from 2023, which is good because it's fairly recent. And we know that these investigations really don't change that much from year to year. So this was for 70 marks and time says 2 weeks. Okay, I'm not sure about that, but normally this is something that you should write in school. So you will be timed, maybe 2 hours, depending on the mark allocation. Okay, here it was 70, so it could have been 1.5 hours. Now, they give us a bit of information about what a function actually is. And it says a function is a relationship between x and y, where for every x value, there is only one y value. So you would have learned that in earlier grades as a one-to-one function, a one-to-one relationship, okay? One x value, one y value. One way to decide whether or not a graph represents a function is to use the vertical line test. So here's something important. Every expression in math can be graphed, meaning that we can draw it out. But not every graph is a function. To determine if a graph is a function, we use something called the vertical line test. Now, if you have already started the section, you would be familiar with it, but remember, investigations are usually tested before you actually cover the section in school. So they expect you to go home, do a bit of research on the topic, and gain a bit of insight about what functions and inverse functions are so that you're prepared for the investigation. So that's what's expected of you. And it says, if any line drawn parallel to the y-axis intersects the graph only once, then that graph represents a function. So there is a very simple test that we can do to check if a graph is a function, and that is known as the vertical line test. All we do is we draw a single vertical line through the graph, and this can be done anywhere on the graph. Here they've just decided to do it on the positive x-axis, but it could have even been on the left-hand side, on the negative x-axis. Okay, so let's go according to how they have it. Here is the vertical line, and what we are concerned with is this line cutting through the graph at one distinct point only. Let's look at graph B. There's the vertical line. It cuts through the graph at that one distinct point. However, if you look at graph C, the vertical line through this graph cuts through the graph at two different points. That means that graph C is not a function. So here's what the vertical line test is about. We draw a single vertical line through a graph, and it is supposed to intersect the graph once, meaning that graph A is a function, graph B is a function. However, graph C is not a function. And that is what it actually states in the information at the bottom. It says, graph A and B are functions. Graph C is not a function because the vertical line intersects the graph twice. So for every x value on the graph, there are two y values. That makes sense, right? Whatever this x value is on the x-axis, say for example it's -3, it would have two y values because these 2 points will have the same x coordinate but different y coordinates. Now that is not a function. That would be a one-to-many ratio, which is not a function. So we are looking for a 1-to-1 ratio. One x value, one y value. Now that we have established how we determine what functions are, let's go on to the first question. Question 1 says, we are given the linear function y is equal to 2x plus 3 And we know that it's linear, it's a straight line because it is in the format y is equal to mx plus c. Here the m value is 2 and c is positive 3. Now, firstly, without even looking at the table, guys, remember your functions notes from grade 10 and grade 11. You even covered straight lines in grade 9. If a straight line has a positive gradient, we are expecting it to slope in that direction. So it says, use the table below to calculate the values of y for the given values of x. Now, this is absolutely basic. All you guys are going to do is take the particular x value and substitute in the equation in place of x. So we're first going to substitute negative 4 in here. It's going to be 2 times negative 4, which is negative 8, plus 3. So this should be negative 5. We're then going to substitute negative 2. So we have 2 times negative 2, which is negative 4, plus 3, that is negative 1. We're now going to substitute 0. So that gives us 3 because 2 times 0 is 0. 0 plus 3 is 3. Now substituting 1, 2 times 1 is 2, plus 3, that is a positive 5, and 2 times 2 is 4, plus 3, that is a positive 7. So these values will form our coordinates, okay? And 1.2 says, use the table to plot the points on the axis system below and connect the points with a straight line. So before I do that, I just want to show you as coordinates, this is what we would have, okay? So the first set would be negative 4 and negative 5, negative 2 and negative 1, 0 and 3, 1 and 5, and then 2 and 7. Now let's plot these points. So we're looking for negative 4 on the x-axis, and that needs to correspond to negative 5, which is here. Next, we've got negative 2 and negative 1. We then have 0 and 3. Then it is 1 and 5. That is here. 2 and 7. So those are the points that we've got. And I know it may look a bit odd because they actually have skipped some values. They didn't give you a point for negative 3 or negative 1, but that's fine. These are more than enough points to draw the straight line. So all I'm going to do is join these points with a straight line. So that is what the graph is going to look like. And they say label the graph as f. So somewhere next to this, we are going to label it f. 1.3 says, complete the table below by swapping the values of x and y in the table above. So here's what they're asking you for. You're going to swap the values for x and y. For every column that you had, you're going to swap those values. Meaning now that all of your x coordinates are going to become y coordinates. So we had negative 4, negative 2, 0, 1, 2. Those now become our y values. Negative 4, negative 2, 0, 1, and 2. And all of the y coordinates that we had now becomes the x coordinates. That is negative 5, negative 1, 3, 5, and 7. So negative 5, negative 1, 3, 5, and 7. Okay, 1.4 says, use the table to plot the points on the same set of axes as in 1.2 and connect the points with a straight line. Label the graph as f to the minus 1. The graph of f to the minus 1 is considered the inverse of f. Okay, so to do this, let's draw the graph in a different color. So I've actually just changed the color of the values, right? Because I want to draw blue to represent this graph so that we don't confuse it with the graph of f. Now, as coordinates, our points are going to be, we're going to have negative 5 and negative 4, -1 and -2, 3 and 0, 5 and 1, 7 and 2. So those are the points that we are now going to plot. So -5 and -4, that is going to be here. -1 and -2, 3 and 0, that is on the x-axis. 5 and 1, that is here. And 7 and 2. Okay, and all we have to do is draw a straight line through these points. So that is what it's going to look like. And they asked us to label this graph as f to the -1. Now they gave you an important bit of information, and they said that the graph of f to the -1 is considered the inverse of f. Now, the whole aim of this investigation is to show you how to draw the inverse of a particular function. And what we have noticed so far is that in order for us to draw the inverse of that graph, what we did was we swapped the x and the y values for f. And by swapping the x and y values, and when we plot those points, it now gives us the inverse of f. So we have established a simple way to draw the inverse of a graph is to swap the x and y values. Let's look at 1.5. It says the transformation that takes place to obtain the inverse of a graph is a reflection in the line. So let's understand this, right? A reflection in the line. If you look at these two graphs, they have been reflected about a certain line. And that certain line has already been drawn for you. It is actually the dash line that's been drawn. And I want you guys to notice that the dash line coincides with all the points where x and y is the same. It cuts through 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5. It does the same thing on the negative x-axis. -1 and 1, -2 and 2, -3 and 3, and so forth. So what does it tell you about this line? This line, which is actually the line of symmetry, the line of reflection, it's actually the line x is equal to y. Another way of writing this is y is equal to x. That means the same thing. Okay, so to come back here, 1.5, it says that the transformation that takes place to obtain the inverse of a graph is a reflection in the line x is equal to y, and is obtained by swapping the, what did we do? We swapped the x and y coordinates. You could say value of x and y coordinates by swapping, according to how they've named it, let's say swapping the values of x and y. Guys, this information alone in 1.5 is the basis on which inverse functions operate. We swap the values of x and y, and when we plot the inverse, we notice that the line of symmetry, or the line of which the original function has been reflected, is the line x is equal to y. And now 1.6 says write the equation of f to the -1 in the form y is equal to. So since they've only given you space here for the answer, I just want to work underneath this and show you how we get that. Okay, the equation of f was given to you as 2x plus 3. Now I just want to rewrite this where I replace f of x and I write it as y, because f of x is y, right? Step 1 is to swap x and y. So we're going to say x is equal to 2y plus 3. Step 2 is to make y the subject of the formula. Now we want to get y alone. So the first thing we're going to do is take the positive 3 over to the left. When I take it over to the left, it becomes -3. And on the right hand side, I'm left with 2y. The next step towards getting y alone is to divide throughout by 2. If I divide throughout by 2, I now have y alone, On the left hand side, I have x over 2, which I can just write as a half x. And the second term becomes negative 3 over 2. So this is actually the equation of my inverse. That is going to be the answer to 1.6. They should have actually left a few lines for you to write your working out. Actually, I think they left 2 lines, so the line actually continued on the next page. So in the form y is equal to, it's going to be a half x minus 3 over 2. That is the equation of the inverse. And I would actually prefer if you guys show your working out, okay? So these steps are important. Now they ask you, is f to the minus 1 a function? And you guys, please remember, what makes a graph be a function is if it passes the vertical line test. So just to show you this quickly, if I were to draw a vertical line, okay, let's draw that better. If I were to draw a vertical line through this graph of f to the minus 1, does it intersect the graph once? Yes, it does. And if I were to draw this line anywhere, see, if I had to move this line, it is going to intersect the blue graph once only. We're just ignoring the red for now, okay? Because they're not asking about that. But yes, if I have to move this line anywhere, it will always intersect this graph of f to the minus 1 once, which means that f to the minus 1 is a function. So for 1.7, we are going to say yes. 1.8 says, give the domain and range of the following. Now, we don't have to scroll back up to the graphs because we know that f is a straight line. And for a straight line, the domain would be x is an element of real numbers. The range would be y is an element of real numbers. And the domain of the inverse, all x values are covered, all y values are covered. So it would be the same. Domain would be x is an element of real numbers, y is an element of real numbers. As long as it is a straight line, this would be your range and domain. Okay, so we don't have any restrictions where we are excluding certain values. We drew the entire graph. So your range and domain would be all real numbers. So we are done with the straight line and its inverse. Question 2 is now based on the basic quadratic function. The basic quadratic function being y is equal to x squared. Now, we know that is a parabola, and if we look at the shape, it is like the smiley face parabola. 2.1 says, use the table below to calculate the values of y for the given values of x. So you're going to take each x value and you're going to substitute in here. But one thing I do want to point out is that the whole x value is squared. So when I substitute, I'm going to have the negative 3 in a bracket and I'm squaring that. I need you guys to please, please, please take note that this is not the same thing. Okay, so if x is squared, you are substituting the value in a bracket. Saying negative 3 squared on your calculator is going to give you negative 9, which is going to be wrong. Okay, so please just take note of that, because that is actually a common mistake that I've noticed learners make. Now the first one, we have negative 3 all squared. That is going to give us positive 9. Negative 2 all squared, again the negative 2 is inside a bracket. Negative 2 all squared is 4. Negative 1 all squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. 2.2 says, use the table to plot the points on the axis system below and connect the points with a smooth curve. So I just want to write down these points as coordinates so it's easier for us to draw. We've got negative 3 and 9, negative 2 and 4, negative 1 and 1, 0 and 0, 1 and 1, 2 and 4, and 3 and 9. Okay, so I'm going to plot these points. Negative 3 and positive 9. That is going to be all the way up here. negative 2 and negative 4, negative 1 and positive 1, 0 and 0, 1 and 1, 2 and 4, and 3 and 9. Okay, so I'm going to go ahead and just draw a line through those points. Okay, so this is more or less what my graph is going to look like. It's just a bit difficult to get this curve at the bottom, but okay, I think that's good enough. We don't actually have space here to make the arrows at the top, so I'll just extend it. And this is going to be F. So they said label this as F. Okay, so that is the graph of F. Then 2.3 says complete the table below by swapping the values of x and y in the table above. So we are following the exact same procedure that we did in question 1, where we're going to swap the x and y values. So all of these x values now become the y values. So negative 3, negative 2, negative 1, 0, 1, 2, 3. So in the next table, let's fill it in where we have y, negative 3, negative 2, negative 1, 0, 1, 2, 3. And all of the x values, all of the y values are now going to become x values, which is 9, 4, 1, 0 and 1, 4, 9. So 9, 4, 1, 0 and 1, 4, 9. So it says, use the table to plot the points on the same system of axes in 2.2. Connect the points with a smooth curve and label the graph as f to the minus 1. The graph of f to the minus 1 is considered the inverse of f. So just like what we did before, I am going to change those values to blue so we can see the difference with both graphs. I just want to write the coordinates here so it's easier for us. It's going to be 9 and negative 3, 4 and negative 2, 1 and negative 1, 0 and 0, 1 and 1, 4 and 2 and 9 and 3. Okay, so let's plot these points. 9 and negative 3. So we've got a positive 9 and a negative 3, which is going to be here. 4 and negative 2, 1 and negative 1, 0 and 0, positive 1 and 1, positive 4, positive 2, and then 9 and positive 3. So notice how it would be the same parabola from before, but now it's as if it's on its side. Okay, so that is what the inverse looks like. Let us go ahead and draw the graph through these points. Okay, so there we have it. That is going to be the graph of f to the minus 1. 2.4 says, okay, so we've just done 2.4. 2.5 says, give the domain and range for the following. Okay, so we first want the domain of f. Now, you guys, the domain of a parabola is always x is an element of real numbers, because what happens is, as this parabola continues, notice how it gets wider, where the left hand side would cover all of the x values and it would go towards negative infinity. Similarly, on the right hand side, as the graph gets wider, it will cover all of the positive x values and it will go towards positive infinity. So if every single x value is covered on the graph, we just say x is an element of real numbers. Real numbers means every x value from negative infinity to positive infinity. Next, they want the range. Now, when we get range of a parabola, range refers to the y values. And you guys would have covered this in your notes, so I just want to put up a note here for you. Range depends on the a value. If it is, let's write this better, if it is a positive a, then your range is y is greater than or equal to, and normally we say q, but I'm just going to change it for now and say TP TPY. So y would be greater than or equal to whatever the y coordinate of the turning point is. But if it is a negative a, it would be the opposite. Y would be less than or equal to TPY. Now we already know that we are dealing with a positive a value, because if we go back up to the equation, this is in the format y is equal to ax squared, where a here is 1. It's a positive 1. So immediately, without even looking at the graph, we know that it's going to be y is greater than or equal to 0. But to refer to the graph, you can see that is true, because on this red graph, the graph of f, the y values are all positive and they start from 0, meaning that y is greater than 0 and y is equal to 0. So for our range, we're going to have y is greater than or equal to 0. Next, they ask you for domain and range of the inverse. And there's something interesting you guys are going to notice. If we look at the domain of the inverse, notice how the x values covered on the graph starts from 0 and it is all of the positive x values, meaning that we would write it as x is greater than or equal to 0. However, the range, if you look at the range, because this parabola gets wider over time, eventually it will cover all of the positive y values and all of the negative y values. Since that would be all the y values from positive to negative infinity, we would write the range as y is an element of real numbers. And I'm not sure if you guys have already noticed this or if you have already learned this, but for a function and its inverse, the domain and range get swapped around. And what I mean is, notice how the domain of the original function becomes the range of the inverse, meaning that we use the exact same format and we just change x into y. Where we had x as an element of real numbers as the domain of f, the range of the inverse is now y is an element of real numbers. And the next thing for you to take note of is the range of f becomes the domain of the inverse. Notice here, the range of f is y is greater than or equal to 0, and the domain of the inverse is x is greater than or equal to 0. So all we do is we change this from y to x and we use it as the domain for the inverse. And you guys know this because remember, x and y get swapped around for the inverse. So whatever information we have regarding x for the original function, we use it as y for the inverse and vice versa. Now 2.6 says, y is the graph of f to the minus 1, not a function. So if we just scroll back up and we have a look at this, if we were to draw a vertical line through the inverse, we notice that it cuts the graph at 2 distinct points, and immediately that is a fail. It fails the vertical line test, meaning that it is not a function. And the reason why it is not a function is because it fails the vertical line test. So I'm going to say that it fails the vertical line test. And I'm just going to elaborate on this point, okay? So the vertical line intersects the graph twice. That's a very simple way to say it. An alternative way that you could answer this question is that you could say for every x value, there are 2 y values. I mean, you could write both answers if you want to do that, if you feel it's safer. But since it's only 1 mark, we need 1 reason, okay? I personally would go with saying that it fails the vertical line test because the vertical line intersects the graph twice. Then 2.7 says, give the restrictions that can be placed on the domain to make the inverse a function, and your constraints may not change the range. Okay, let's understand this. Now, you guys, I am just going to draw this separately for you. Okay, so now you guys, here is what we can do to a parabola so that its inverse is a function. So I've got here, to make the inverse of a parabola be a function, we restrict its domain. There are two ways of doing this, okay? Either we can say y is greater than or equal to 0, meaning that we are only drawing half of the parabola. So we're drawing the half where, actually, sorry, this is x. Let's just change that. Yeah, we are restricting the domain. Remember, domain are x values. So we are only drawing half the parabola. We are either drawing the half where x is greater than 0, meaning all the positive x values on the graph, or we are drawing the half where x is less than 0, meaning all the negative x values on the graph. Now, you may be wondering, how does this make the inverse be a parabola? Okay, so if these are f, I'm just going to go ahead and draw the inverse. This is now what their respective inverses would look like. So you can see that if you are going with the right hand side of the parabola, this is what the inverse would look like. If you are going with the left hand side of the parabola, that's what its inverse would look like. Now, how exactly does this make it be a function? Let's see. Now, if we draw a vertical line through the inverse, notice that it only intersects the inverse once. And actually, no matter where you move that you move that vertical line on the inverse, specifically the blue graph, okay? It's only going to intersect the blue graph once. Likewise, on the right hand side, if we draw a vertical line through that inverse, it is going to intersect the inverse once only. So this is extremely important information. This is something that you are going to apply when you do your past paper questions as well, something you're going to apply in your exam also. We restrict the domain of the parabola. So either we go with x is greater than or equal to 0, or we go with x is less than or equal to 0. Now let's go back to that question. So here it is, 2.7. Give the restrictions that can be placed on the domain to make the inverse a function. So they say that your constraints may not change the range. Notice how all we did was we restricted the domain. We don't touch the range at all, okay? So we're going to say exactly those two conditions that I gave you. We're going to say x is greater than or equal to 0, or x is less than or equal to 0. So those are the two things that we can do. That is how we can restrict the domain. Now 2.8 says write f to the minus 1 in the form y is equal to. So let me show you the whole process of how we get there. Starting off, we have f of x is equal to x squared. I'm going to write it as y is equal to x squared. Step 1 towards getting the equation of the inverse is we swap x and y. So we're going to write this as x is equal to y squared. Step 2 is we make y the subject of the formula. Now to make y the subject here, we are going to get rid of the square, so we're going to square root both sides. However, please remember that in front of the square root for the x, it has to have a plus or minus. That now gives us the equation of y as y is equal to plus or minus the square root of x. So that is the equation of the inverse. Okay, next we have question 3. And it says the basic exponential function y is equal to b to the power x, where b is greater than 0, so b is the base, and b is not equal to 1. Now yes, this is the very, very basic exponential function. It says use the table below to calculate the values for y for the given values of x. So all we're doing is we are given the base of 2. We are replacing x with all of these values. So starting off with -3. That is going to give us, just to show you what it's going to look like, it's going to be 2 to the power -3, which is going to be 1/8. Next value, -2, so we've got 2 to the power -2, which is 1/4. 2 to the power -1 is 1/2. 2 to the power 0. Anything raised to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 2 is 4, and 2 to the power 3 is 8. So we now have all of our values, our table is full, and if we know anything from the first two questions, we know that the next question here is going to ask us to sketch. So I am just going to write these as a set of coordinates so it's easier for us to see what we have. So those are going to be our points. Now let's plot those. We've got -3 and 1/8. Okay, but before I plot any of those coordinates, I just want to remind you guys that exponential functions have an asymptote, particularly a horizontal asymptote. And the horizontal asymptote is usually given in the equation, where the normal equation is in the format a times b to the power x. There could be a p-value, so like a horizontal shift, plus q. But that q value is responsible for being the horizontal asymptote. However, if you look at the equation given, there is no q value. So please remember, if there is no q value, that means that the horizontal asymptote is equal to 0. So what is 0 exactly? It means that y is equal to 0. Now, you guys, if you look at y is equal to 0, that is basically the entire x-axis. So to show that, I'm going to draw a dashed line through the x-axis and label it y is equal to 0, because that is what the asymptote is. So here is my asymptote, and why is it important for us to do this? You guys remember that the asymptote is a point or line on the graph where the graph is undefined. Also, the fact that it's undefined means that your graph cannot touch that line. So it's important to have it there. Now the first point we have is -3 and 1/8. So 1/8, that's 1/8, which as a decimal is 0.125. So it's going to be slightly above this line. To estimate it, I'm just going to have it here. Okay, so here I've got it, right? Slightly above the line to show that it's the 0.125. Next, I've got -2 1/4, which is going to be a little bit above that. Now, it's difficult with these values because they are so small and these blocks are so tiny. We've got -1 1/2, so that's going to be directly in the middle. We've got 0 and 1, that is our y-intercept. We've got 1 and 2, 2 and 4, and we have 3 and 8. So those are all the points of this exponential function. I'm just going to go ahead and join them. And we are going to label this f. So I want you guys to notice that when you are drawing your exponential function, you go as close as you can to your asymptote, but do not touch the asymptote. So that is the graph of f. 3.3 says complete the table below by swapping the values of x and y in the table above. So we've done this in the previous two questions. We know how this works. We are going to take all of these x values and now make them y. So our y values are going to be -3, -2, -1, 0, 1, 2, 3. All of our y values here are going to become the x values. So that is going to be 1/8, 1/4, 1/2, 1, 2, 4, 8. 3.4, use the table to plot the points on the same axis system as in 3.2 and connect the points with a smooth curve. Okay, So I'm just going to change these to coordinates. It's going to be 1/8 and -3, 1/4 and -2, 1 and 0, 2 and 1, 4 and 2, and 8 and 3. So these are the points that we're now going to plot. But before I plot these points, I want to start off by filling in the asymptote for this inverse of the exponential function. And you guys, since x and y are swapped around, all of the information for the inverse comes from the exponential function where we swap x and y, meaning that for your original function, which is the exponential, the entire x-axis was the asymptote. For the inverse, now the entire y-axis would be the asymptote. So notice how x and y are getting swapped around. So I'm going to go ahead and draw a dashed line through the y-axis, and its label will be x is equal to 0. So here it is, x is equal to 0, that's my asymptote. And now I'm going to start off by plotting these points. So I've got 1/8 and -3, which I'm going to take somewhere here. I've got 1/4 and -2. 1 and 0. Okay, so I've went ahead and plotted the rest of those points. I'm now going to draw a straight line through them. Not a straight line, actually, sorry, a curved line through them, because this is the inverse of exponential. Okay, so here we have it, and we are going to label this f to the -1. And you guys notice how here is your axis of symmetry, y is equal to x. When you look at a function and its inverse, I'm just going to zoom out a bit so we can see the whole diagram. When we look at a function and its inverse, you guys notice that they should be a mirror image of each other. That is why we say that they are reflected over this line, because if you had this on a page and you were going to close the page along this y is equal to x line, they should come together perfectly. Okay, let us go on. So we've done 3.4, and then 3.5 says, is f to the -1 a function? Now to understand this, we need to have a look at the vertical line test. If we were to draw a vertical line through this point, it does intersect the graph once. So yes, it is a function. (3.6) To be able to write down the equation of f to the -1 in the form y is equal to, we must use logarithms. According to the log definition, y is equal to b to the power x can be written as x is equal to y base b, or it's x is equal to, log base by. Now, that is extremely important information. The inverse of an exponential function is a log function. So you guys, what we have just drawn here as f to the -1, its name is a log function. So exponentials or exponential functions and log functions are inverses of each other. Now, just to show you how we are going to get the equation of the inverse, starting off with what we have, y is equal to b to the power x. The first thing we're going to do is swap x and y. So we have x is equal to b to the power y. Now we want to make y the subject of the formula, but y is here in the air as an exponent. So we need to bring y to ground level in line with everything else. And the only way for us to do that is if we introduce log. So we're going to bring y down, and at the same time we're going to have log on the right hand side. So think of log as a means of anchoring y down, where y was initially in the air and we needed to bring it to ground level, so we are using log to ground it. Now what happens is whatever was the base of y becomes the base of log. So this is written as a subscript b. It's a little lower next to log, and whatever is on the left hand side goes in line with log. So this is what we would do. Okay, this is the method, and this is basically your inverse. So we have y is equal to b to the power x. We swap x and y, and then we make y the subject by introducing log on the right hand side. Now I just want to correct this because this is just a general way that I was showing you, but remember in the equation that we had, the base was 2. So notice here, the equation of your inverse is going to be y is equal to log base 2x. Okay, so this is basically it. That is the equation of f to the minus 1. Next, we have questions based on the domain and the range of these functions. So the domain of f, if we have a look at the domain of f is an exponential function. Domain of exponential functions are always x is an element of real numbers. If we have a look at the range, so range for exponential functions all depends on the a value. So very similar to parabolas. If a is positive, then we say y is greater than or equal to q. And remember, q is the horizontal asymptote. If it is a negative a, then we say that y is less than, actually, let's remove this. Y is greater than, y is less than q. That is the horizontal asymptote. The reason why we shouldn't have the equal to in it is because the graph cannot equal to that y value because it's the asymptote. So it could either be everything above or below. Now, we have established that from the exponential function that we had here, the q value was 0. And since it is a positive a, remember, a would be the coefficient here of b. If there's nothing showing, then we take a as 1. So right now in front here, a is 1, which is a positive 1, meaning that we're using the format of y is greater than q. So I'm going to say, for my range, y is greater than 0, and y is an element of real numbers. So two parts to it, right? But this is actually the main part. That is the restriction of it. Now to answer the next part, we're going to use what we learned in the previous question. We learned that to get the domain of the inverse, it is the same thing as the range of f, but we write it in terms of x. So we're going to have x is greater than 0, x is an element of real numbers. For the range of the inverse, it is the same as the domain of f, but we write it in terms of y. So the domain was x is an element of real numbers. We're going to write it as y is an element of real numbers. So that actually concludes question 3. Now when we look at question 4, it is also another exponential function in the format y is equal to b to the power x, but this time b lies between 0 and 1. So we can expect fractions like 1 over 2, 1 over 4, 2 over 3, etc. Where if we convert them to a decimal, it's between 0 and 1, so 0 point something. 4.1, use the table below to calculate the values of y for the given values of x. Now, the base is a half, so where we have x as the exponent, we are going to substitute all of those x values in place of it. Feel free to pause the video and attempt this. I am going to pause the video and go ahead and fill in these values. So here are all of the y values. 4.2, we know that we're going to be asked to draw this graph, so I'm just going to write these as coordinates. So those are going to be the coordinates that we will plot. Now again, we do not have a q value here, but exponential functions always have a horizontal asymptote. If there is no q value, the asymptote is y is equal to 0, which is the entire x-axis. So here it is, and I've labeled it. Next, I am going to plot all of those coordinates. So that is what my graph would look like. And I have labeled it f. Let's go on to 4.3. They say complete the table below by swapping the values of x and y in the table above. So this is the fourth time doing this. We know how it works. From the table above, we are taking all of the x values and making it y values. We are taking all of the y values and making them x values. So that is what the table would look like. 4.4 says, use a table to plot the points on the same system of axes as in 4.2. Connect the points with a smooth curve and label the graph as f to the minus 1. So we are plotting all of these. I just want to write them as coordinates first so we know what we're working with. So these are the points that we are working with. Now firstly, if the exponential function had a horizontal asymptote, the inverse would have a vertical asymptote. Remember, everything gets swapped around, okay? So here is the vertical asymptote, which I've labeled as x is equal to 0. Next, I am going to plot these points and draw the function. So I've plotted those points, and that is what the inverse is going to look like. Now remember, f is an exponential function, so its inverse is a log function. And the line of symmetry here is a line y is equal to x. So they are a mirror image of each other. And if you were to fold your page along the line y is equal to x, both halves of the graphs should come together perfectly. Okay, let's have a look at the next question. So 4.5 is based on domain and range. We don't even have to look at our graph to answer this. We know that the domain for exponential is x is an element of real numbers. The range here, the graph was drawn above the asymptote, so it's all positive y values. So we're going to say y is greater than 0, y is an element of real numbers. To get the domain of the inverse, we are going to look at the range of f, and we're just going to change it to x. So x is greater than 0, x is an element of real numbers. To get the range of the inverse, we are going to look at the domain of f, and we are going to change it to y. So we're going to say y is an element of real numbers. And 4.6 says, write down the equation of f to the minus 1 in the form y is equal to. So we had y is equal to a half to the power x. The first step is to swap x and y. So we're going to have x is equal to a half to the power y. The next step is to make y the subject. And to do that, we are going to, remember we said that y is up there. We need to bring it down in line with everything. And to do that, we introduce log on the right-hand side. Whatever is the base of the exponent becomes base of log, and x goes next to that in line with log. So this would be the equation of the inverse. Let's go on to question 5. So question 5 says, consider questions 1 to 4 and complete the following conclusions related to inverses. The transformation that takes place to obtain the inverse of a graph is a reflection in the line x is equal to y, or as they have it, y is equal to x, which is the same thing, and is obtained by swapping the x and y values. Then, regarding domain and range, it's exactly as I mentioned, you guys, that the domain of f becomes the range of f to the minus 1, and the range of f becomes the domain of f to the minus 1. So everything gets swapped around to draw your inverse, including range and domain of f. The domain of f becomes a range of f to the minus 1, and the range of f becomes the domain of f to the minus 1. So that actually concludes this investigation for 70 marks. And this investigation covers all of the basics regarding functions and their inverses. It's basically all of your grade 12 content for functions. I wish you guys all the best for your math investigation.